Hi, folks. Welcome back to our 4.6 part 2. And so in this part, we're going to continue looking at exponential equations, but really focusing on the cases when the bases are not equal to each other. Okay. All right. So let's begin with example 4. So in example 4, we can see that we have 4 to the x equals 7. There's nothing to divide. It's really hard to rewrite, like 4. How do I put 7 as 4 to some power, right? And so in this case, we are going to go ahead and rewrite in exponential form, or sorry, in log form, right? So let's go ahead and rewrite in log form. All right. So when we rewrite this in log form, whoops, we have our base to some power equals, in our what we know, we said 7 is really like y over a, right? We took that a that was in front of the 4, we divided it over, and then we got 7. And so if we want to rewrite this in log form, we're going to have log. The base is going to be the same base that we had over in the exponential form. Base 4 of 7 equals x. All right. So now we have our y over a, our base, and we have the thing we don't know all on one side by itself. Very convenient. Okay. So if we are in a situation where there's no calculator, this is a perfectly fine solution. In fact, a lot of times when they say leave it in exact solution or leave your solution in exact form, they mean this. They mean write it like a math textbook, a mathematician, all right? We just leave it like that. We don't need to turn it into a decimal. But I do want to talk a little bit about how we might write this in other ways, okay? So it turns out that x equals log base 4 of 7 can be written in a few ways. We can actually write this as log of 7 over log of 4, right? And so if we're into the color coding, we're notice that the 4 is the base. That log of 4 goes in the denominator. And log of 7, that 7 goes on the top, okay? So if you type this into your calculator, then you can get a numerical value. But I want to caution us on a few things. A lot of times when we type log into a calculator, it actually opens up a parentheses for you. And so what we need to do, if we're typing this into the calculator, we actually want to say log, calculator opens up a parentheses, you type in 7, and even though you didn't open the parentheses, you have to close it. And then you can type divided by log, again, open parentheses, 4. And the last parentheses you don't really have to close, but if you want to sort of make them all match, then you close that off. Okay, so if you type this into the calculator, you should get a numerical value for this. All right. So if My Open Math is asking you to round to the decimals, then you want to type it in this way. But if it says exact value, you leave it this way. Okay. Now, it turns out that you can actually also type this in like this. ln 7 over ln 4. The 7 is still on the top, 4 is still on the bottom. But what we're doing here is we're using log with base e instead of base 10, okay? So in this one, we're using the common log, but in this one, we're using our natural log, okay? And same thing, if you want to type this into the calculator, ln, open, 7, close, and then divided by ln, open or close. Okay. So 2 different ways that you can type this into the calculator, and more than just typing into this into the calculator, we refer to these as change of base. All right. So when someone says change of base, what they mean is change it from base 4 to either base 10 or base E. All right. All right, let's take a look at example 5. All right. So example 5 kind of looks the same, but has this plus 200 number there. Okay. And so what we're going to do for this question is we're actually going to subtract that 200 to the other side. So minus 200, minus 200. And that leaves me with 1/3 to the x equals 100. Okay. Now that we call this isolate our logarithm, or isolate our exponential. Okay. So we have isolated our exponential. And I know this when I have my base to some power equals a number. Okay. Now, after I isolate, I go ahead and I rewrite it in log form. In other words, I'll have log base 1/3 of 100 equals x. All right. So this is our rewrite in log form. And we've got our y over a, our base, and our unknown, all on one side by itself. Okay. So if someone walks up to you on the street and says, what's the exact answer? You say, this is my exact answer. Log base 1/3 of 100. But if someone else says, I actually want you to change the base of that, right? You could do x equals log pink number over log yellow number. Or you could say natural log 100 over natural log 1/3. And all of those would be count as changing the base. Okay. All right, so let's get these 2 questions on one page by themselves. All right, so taking a look at these, we rewrite in log form after we've isolated our exponential, and then we leave our answer in exact form most of the time, unless someone specifically says, hey, type that into a calculator and see what you get. Okay. All right, let's take a look at examples 6 and 7. So one of the things you'll notice here is that in example 6 and 7, you actually have exponentials on both sides, right? So in example 6, I've got a power of 4, or sorry, base of 4 and base of 5. And over here, I have base of 2 and base of 5. And if I think back to the previous video, I might notice that there's not really an easy way to make these bases the same, or to make these bases the same. Okay. And so we're going to have a specific strategy on how to solve questions like this. The easiest way to go about this, I think, is to actually take the natural log of both sides. All right. So this is sort of weird, but when we're looking with equations, if we do something to both sides of the equation, that is perfectly valid, right? So as weird as it would be, I could take this and add a 1 as long as I took this and added a 1, right? Or I could multiply this side by pi as long as I multiply this side by pi. It doesn't really matter as long as I do the same thing to both sides. So in this case, I'm going to go ahead and take the natural log of both sides. Okay. And then I'm going to think back to 4.5. And I'm going to say, hey, there was that log property where if I had a power, I can move it down to the coefficient. And turns out I can do the same thing on the other side. Okay. That means I can write it as 2x plus 3 times natural log of 4 equals x minus 2 times natural log of 5. Okay. And the reason that we can do that again is because of that log property, the power property. All right. Now, I'm going to take this natural log of 4, and I'm actually going to distribute it to both terms in the parentheses. And then we're going to do the same thing on the other side. We're going to distribute that. Okay, so I'm going to distribute here and here, and then here and here. And I will get 2x natural log 4 plus 3 natural log 4 equals x natural log 5 minus 2 natural log 5. Now, if you think back to when we did inverses in chapter 1, there was a sort of inverse problem where like we made it a lot worse before we made it better. Okay, so in particular, we saw questions like if f of x equals something like x plus 2 over 3 minus 4x, then we define the inverse, okay? And then we would switch the x's and y's, and then we would distribute, and then we actually collected all the terms with y on the same side. And so we're actually going to apply a similar reasoning here, where I'm going to collect the terms that have an x to one side, and on the other side, I'm going to go ahead and put the terms that don't have the x. And so in this case, I'm going to have 2x natural log 4 minus x natural log 5. And then I'm going to take this purple term and I'm going to subtract it to the other side. So I'll get negative 2 natural log 5 minus 3 natural log 4. And so I have my red terms on one side and my purple terms on the other side. The clever trick now is both of my terms in red, they have an x in them. So I can actually factor out the x. Let's see what we have left. 2 natural log 4 minus natural log 5 equals, I didn't do anything to this side, so I can leave it the way it is. And now if I want x, all I have to do, is take this and divide it to the other side. So I get x equals negative 2 natural log 5 minus 3 natural log 4 over 2 natural log 4 minus natural log 5. And this, my friends, is the form in which I want to see our answers. All right, so in other words, I want to make sure that we have exact solutions for questions like this, okay? All right, so we're going to do one more question like this, example 7. But if you'd like to try that one on your own, I encourage you to pause it right now and then come back and check with the video when you're done, okay? And if you're still here, we're going to take a look at example 7 together. All right, I see two exponentials. I see their bases are different. If this were an 8 instead of a 5, I would actually think it's more like the questions from video 1. Okay, or if this 5 was a 4, I would say it's more like the videos from number 1 or the video part 1. But the 2 and the 5, they're really hard to make look like each other. So I'm just going to go ahead and natural log both sides. And in natural logging both sides, now I can use the power property, or the power property, and I'm going to bring that power down to the front on both sides. Okay. And then I'm going to sort of make things worse before they get better. I'm going to distribute on this side. I'll distribute on the right side as well. And I'll get 2x natural log 2 minus 3 natural log 2 equals x natural log 5 minus 2 natural log 5. I think about the terms with x. I think about the terms without x. And I think I want to clump all the red terms on one side and all the purple terms on the other side so that I can factor out an x. 2x natural log 2 minus x natural log 5 equals 3 natural log 2 minus 2 natural log 5. All right, we've clumped on both sides, and now I can factor out the x. And I can go ahead and divide to solve for x. And here, my friends, is our exact solution for number 7. Okay. Now, I do want to go back here for a moment and go back to this line. All right. So what I did here, I took all the red terms and I moved them to the right-hand side. And then I took the purple terms and I moved them to the right-hand side. But some of us might be sitting out there saying, well, I actually moved the red ones to the right and the purple ones to the left. And so I just want to show us that we can get sort of a different version of this answer. And that might look something like this. 2 natural log 5 minus 3 natural log 2. So these are my purple terms equals x natural log 5 minus 2x natural log 2. All right. So I'm free to move the terms, the like terms, to whichever side. Like that part doesn't actually matter that much. But the rest of the process here is actually going to be same. Like we moved everything to one side with the red so that we could factor out the x so that we could then divide and get our answer. And so if I follow that through here, I get something like this, and then I divide both sides by x, or by the thing in the parentheses. And I get this. Okay. So both forms of these answers are acceptable, all right? Both forms are acceptable. Now, last thing I'm going to talk about on this video, some of us might be thinking, well, that answer looks really complicated. How come we can't just cross out these and cross out those? Okay. Well, here's the deal. If I want to cross out this natural log 2, I also have to divide this term by natural log 2. Right? I'd have to divide every single one of these 4 terms by natural log of 2. I can't just pick and choose the ones I want, all right? However, if this changes to a multiplication and this changes to a multiplication, then you can reduce, okay? But with addition and subtraction, no go. Multiplication, yes, you could simplify, all right? All right, let's get those last two problems on one page by themselves again. This is the second video. Come on back for the third video where we take a look at factoring and how that plays in with the U substitution into exponential equations. All right, see you back here.